Hi, it's Mr. Rops.
And Mr. Cole.
And we're going to look at this, we're going to justify patterns today. And from class, we did this pattern, but I'm going to quickly go through it just so you can see it. Pause it if you need. If I have one table, there were 6 chairs. 2 tables were 10 chairs. 3 tables, if you draw it out, you'll end up with 14 chairs. And so we can see there's a first difference of 4. And so if I have my first difference of 4, I know that chairs will be 4t, and then I have to find my constant, and if you remember from class, it's plus 2. So here is my general formula. I want to try and justify it algebraically. And when I justify it algebraically, there's 2 things I have to consider. I want to find it by formula, and I want to find it by pattern. But it has to be the general case so that it works for all of them. And I know if I look at my table here, if I would extend this table, eventually I'm going to have what I call the kth table. Okay? Which would mean I would have 4k plus 2 chairs. All right? So there is my table. If the next table is going to be k plus 1, I know from the pattern, what do I have to add to this by the pattern, Mr. Cole?
Okay, so we know it's going to go up by 4 from one to the next.
So it's what I had, 4k plus 2,
yep.
And I'm going to have to add 4 to it.
Okay.
If I do some simplifying, that is 4k plus 6. So my k plus 1 table should have 4k plus 6 chairs. And this is for the k plus 1 table. This was by the pattern. Okay, I'm going to put by pattern here. Specifically adding by 4. If I'm going to go by formula now, well, I'm going to find the k plus t is k plus 1 is the one I've been looking for. So I plug t, and c will be then 4k plus 1 plus 2. And if I simplify it, I get 4k plus 4 plus 2, which is 4k plus 6.
So we've got the same thing.
And that is the whole key. If I have this by formula equal to this by pattern, I have then justified it algebraically. This is the general case. It's going to work for any value of k now.